All right, just a few more hours of Web Summit to go. I see a lot of full brains. I'm going to try to cram in a little bit more in the next 45 minutes or so. I've actually got a lot here, so hold on to your seats. How many of you here attended my session yesterday? Just so I have context. Okay, mostly not. That's good. I don't have a lot of repetition. I have some referrals back, so in any case, let's jump in. So I'm going to talk about knowledge layers and agents and how to build better agents that can make the bar into the 5% of applications that are working. But before we talk about how to build agents or what we're building, let's even talk about the elephant in the room, which is as SaaS founders. So I'm assuming you're mostly founders? Okay. So if you're building a company, let's say a SaaS company or any other company for that matter, you're kind of squeezed between two possible very bad outcomes. One is that your potential customer rolls their own version of your product through vibe coding and takes your market. And then the other one is some other big SaaS vendor comes out with a feature that actually is your product idea. And I believe there's an opportunity in here for a new next generation thriving ecosystem of SaaS, but how do we get there? So let's talk today. The main point of today is to talk about how do you get there and how to think about this, and then what are some tools that you can use to get there. So it sounds like bad news, but as we say, how do you turn the lemons into lemonade? And one way you don't do it is by what Satya is saying here, which was a podcast earlier this year on the BG Squared podcast. The notion that SaaS businesses application exist, that's probably where they'll all collapse, because if you think about it, they're essentially CRUD databases with a bunch of business logic. So this is one way to be sure to be disintermediated. You don't want to just be an application layer on top of just taking user input, putting it into a database, and then serving it back up. And the same is true of an LLM. You don't just want to be a layer on top of an LLM. So don't do that. Make sure you have a richer application, not a thinner application. But let's drill down. I believe there are 5 different key areas of differentiation that you can seek out being a startup. The first is if you have any access to valuable or proprietary data. The second, if you can create some community network effects amongst end users or amongst peers. Another is just you obsess about a particular problem. And let's say that particular problem is something that every company has, like accounting. Now, companies aren't going to put a lot of money into solving for accounting super, super well, because it makes more sense for them to put money into something that affects their top line. But if you can create an amazing solution that is unparalleled for something that companies need, but that they're not going to invest in themselves very much, then that's another area. And that goes hand in hand a bit. If you can package it in an amazing UX, so much the better. And then, of course, the litmus test is it can't be something you build easily in an afternoon in AI. And at the same time, customers now have new expectations. Your customers have new expectations. One is interoperability with their AI environments, because they are going to be, and they already are, they have AI infrastructure and are building apps themselves. And so how do you make sure that your app can interoperate with that? For example, having agentic interfaces that can engage with other agents that the customer has created, first party, third party, and vice versa. Another one is you don't want to trap your customer's data. Now, you might think, hey, if I own a certain part of data, then I'm going to be more valuable and the customer is going to really need me. But at the end of the day, if you're trapping their data, increasingly companies understand that their data is a huge competitive advantage and they want to use it in different ways. So making sure that your platform can unlock their data or doesn't lock in their data and has ways to use it more broadly is another expectation to manage. Of course, you have non-functional expectations as well around security in particular, very high bar for security these days, especially with AI, and showing that you can be reliable and that they can trust you with their data. Next is explainability, that for enterprise use cases, oftentimes if the stakes are high, you don't necessarily need every transactions to be explainable, like the whole point of agents is to let them do work, but to have that option for explainability, at least as part of the selling process, but also as part of the audit process, so that when you need to audit, you can. And then goes without saying, people are going to buy your software as a result of the business value. Now, if you're on the other side of this, if you're not building software, you're buying software, these are all good things to keep in mind, because what you want to build is everything that doesn't fit into this, and what you buy is everything that does. So this one really applies to both sides. There's another opportunity for differentiation, which is your architecture, because a lot of your customers are companies that have been around for a long time, at least in the B2B space, who have, edifices that have been built over decades and use a lot of legacy and traditional technology, and then you've got access to all the latest, coolest stuff. So if you can design your architecture now in a way that is flexible and capable and gives you advantages for the future, that is another opportunity for competitive advantage. Obviously, all the other stuff that we talked about still applies. So let's talk about what that architecture looks like, and let's talk first about it from an application perspective before we talk about the data foundation. So how we develop applications is changing, and you don't need a bunch of journalists to tell you this, you already know it. Why we build applications doesn't change. You still have the same business reasons. There's some problem to solve, there's a business process to map, there's a question to answer, whatever it is. But what are the ways in which applications are changing so that you can make sure that your architecture is entirely taking advantage of all the new stuff on the right, and not, you're not using old, brick and mortar techniques. And one is, we're going from having predefined workflows on simple create, read, update, delete data models to having dynamic, context-aware, autonomous applications. So this is the world of agents. And then if I drill down specifically, what does that mean? It means going from static logic to dynamic reasoning. So hard-coded rules that are defined at compile time, or when you write the code, to applications that can read, reason, adapt, make decisions in real time, adjust based on goals, changing context, changing inputs. That's one. Next one is moving from request response to goal-oriented, where with respect to response, you're just reacting to user input in a pre-programmed way. And from goal-oriented, you're pursuing goals in a way that evolves and adapts over time and learns from feedback. We're also moving from monoliths to composable systems, from tightly coupled to more loosely coupled, back to the point around your applications are going to need to interact with other agents from other applications. From code-centric to prompt-driven, so our behaviors defined by code to actually being defined by prompts and models and interactions between different models and agents. And then from CRUD to context, where importantly, and the distinction here is facts about a given thing and retrieving that versus actually what are the things going on around that thing. Yesterday in my talk, I gave the example of Sarah, who has some previous transactions. Those transactions have things in a shopping cart. Those might have some returns and some complaints associated. She has members of a household. That member of the household has their transactions, their complaints, and so on. That's the context, is all the things around versus just retrieving facts about something. So that's the summary on the application side. And then let's talk about the data side. So what is the data infrastructure that everyone has today, all the companies and existing applications? It's mostly stored in rows and columns, which means it's mostly static, which is good at solving relatively fixed questions that have predefined answers and doing store and retrieve. but tables aren't dynamic from the perspective of, oh, okay, now I want to bring in a new data set this week, and I want to bring in 2 new data sets this week and 3 new data sets next week. Each of those requires evolving the model. That's a pain in the neck if you have a relational model. So there are limitations in the data layer, and of course things are spread across silos, and there isn't a real good way to bring the information together from across all the silos. Now, before I get into the solution, let's talk about, well, what are the requirements? What do I need for knowledge for agents? And now, we're used to talking about how do agents act, but okay, how they act is going to depend a lot on what they know. So knowledge ends up becoming a pretty important determining factor. So what do you need in a knowledge layer for agents? First of all, if you're building an application, you're going to need to be able to do like transactions, reads and writes in a relatively low latency kind of a way. Analytics is also nice, and if I can augment that transactional data, so much the better, but I'm going to need some kind of low latency updates and retrievals. You want to be able to have structured data, unstructured data, and then tying it together into semi-structure. You're going to want to be able to bring the data from the silos together. Now, you may not do it all at once. I'm not a big boil the ocean kind of person, just start with one and then add another, but you want a layer and a framework and a technology that lets you bring data in progressively and connect up the silos. You want to be able to have your RAG corpus, so your vectors, along with your agentic memory. Memory is increasingly something that's being handled with graphs. There are at least half a dozen agentic memory vendors I've met lately, Zep, Cogni, Mem0, Paper, etc., all of whom have used graphs for memory on the back end as a first-class option. And then last but not least, the problem with LLMs and the problem with vectors is there's no ability for discernment, i.e., what data do I use for what purpose at what time, depending on the privacy and security and other kinds of access controls. It's a little bit of a, once the model has access to it, it will use anything for any purpose. In the enterprise, most applications have some form of data governance or access control, so you also need that in the model. So this all becomes a foundation for what is the solution to this. It's increasingly many companies are beginning to solve the, how do I get from the 95% failures into the 5% of success, and doing it with the knowledge layer. So this turns raw siloed data into connected contextual knowledge. One way in which I think about data versus knowledge is data is everything. There's a lot of noise. There's a lot of signal, but it's buried in the noise. And how do you find the signal? Well, some of the signal might be hidden, like needle in haystacks, and then some of the signal may require some aggregation, summarization, synthesis, pre-processing of the noise. So that's knowledge, and knowledge doesn't, the size in terabytes or gigabytes of the data, of the knowledge, might represent just 1% of all the data in the company, because we're not talking about everything, we're talking about the signal and bringing the signal together. So you end up with a lot of architectures looking like this, with apps, agents, tools, all accessing a knowledge layer. One of the things I talked about yesterday was how, if you don't have one single point of reference for knowledge for all of your agents, you might end up with your agents, you will end up with your agents each coming up with different answers. So it's like the metaphor of the blind man and the elephant, where one touches the trunk and is like, oh, this thing's like a snake, and then another touches the tail and it's like, this thing's like a broom, and another touches the leg, it's like, this is like a tree trunk. You don't want that with your agents. You want them to have a coherent view. So what this does is it gives you structure, context, and meaning, uniform memory and retrieval. It bridges human and machine understanding, links and unifies data sources, and that data is stored as a graph. And when I talk about bridging human and machine understanding, one of the great things about representing data as a graph is you're basically taking any data that shows up as a network representing it as a network. So you don't have that impedance mismatch of trying to shove a network into a table and then dealing with it there. And but then I can examine it, I can look at it, and it's a pretty human, natural thing to look at nodes and relationships and actually be able to see the data. Whereas if you put the data in a vector database and you look at a vector, it's just a whole bunch of floats. It's an array of floats. You can't make heads or tails of that. And then where does the knowledge layer sit? It's basically back-ended by all the other places in the company where you already have data. It could be more on the analytics side, as Snowflake or Databricks or BigQuery, or it could be transactional systems. It can flow through or flow directly into. And again, usually you start with one application, one or more, small number of systems, and then you build out more gradually over time. Now, what are the roles of a knowledge layer? I'm going to summarize something that I presented in a little bit more detail yesterday. So the recap is it provides better context for agents and as a result, better answers, number one. Number two is it connects the silos. Number three is it gives you knowledge transparency and an option for determinism. What do I mean about an option for determinism? It means there are two ways in which I can use the knowledge layer. I can pull a bunch of context back. So the people Philip knows, what they've bought, what they're interested in, pull that back to the LM, and then the LM will then make a better answer because it has more context. A supply chain is another example. I'm going to take this particular product and then all the different component parts of parts, all the suppliers, how it flows through the supply chain. I might send that all up to the model, and the model may or may not do a good job with that. It turns out that supply chain is oftentimes like 20 levels deep with all these different components and subcomponents, and it involves math. And models aren't very good at any of that. And it turns out you can compute exact answers to those kinds of questions if you just ask the model to delegate that question to the graph database by taking the English or Portuguese or choose your human language, convert it into Cypher, which is the standard language for graph querying, happens to be an ISO standard, is GQL in the form of GQL. Takes the query, does the pattern match, gives you an exact answer, which by the way is explainable, and then feeds that back through the model. So we're seeing this pattern a lot, and I'll give you some examples of customers who are. But it's customers like Walmart, Uber, Intuit, Adobe, Novo Nordisk, who all have this architecture, and it's a combination of send context back to the model so the model can reason better, and have the model translate the question into a question that can be reasoned about in the graph and pass it through. It's kind of like left brain, right brain. If you ask have the right brain is more creative, let's say stereotypically, and the left brain is more rational and linear. So if the right brain gets a question that's more rational and linear, okay, well now I have a left brain, I can pass it over, co-process, and then send it back. Data protection we talked about, so having fine-grained access controls, and then handling of complex questions. Something that surprised me, but that I now have seen half a dozen customers present about on stage, is that the more complex a question gets that someone asks of an AI system, the bigger your SQL query, right? If you're gonna turn it into SQL. And there reaches a point where if I've got a 14-way join and a bunch of recursive queries, the model becomes less and less accurate in generating a query that will actually work. And it turns out that because the Cypher language is much more terse, a SQL query this big might be a Cypher query that's 3 or 4 or 5 lines. And there's a much higher rate of accuracy in generating the query, and then that query actually runs much faster in the graph, because that's what it's built for. So that's what I mean by handling of complex questions. So now let's go back and map the top problems that we have with AI, and how many of these we just solved with an AI knowledge layer backed by a graph. So AI hallucinates. It's a black box. I don't know how it makes decisions. They have no discernment. I'm using the term discernment to refer to knowing what data is used what data you should use for what purpose based on access controls, and then models lack context, meaning they aren't very good at multi-level out context, especially of your own business domain. They've been trained on the world, they haven't been trained on your business, and even if they were, they would still have all the problems on top. And so with the knowledge layer, you get better accuracy, or you can entirely solve for hallucinations by having an option to run deterministic queries in the graph. You solve black box by getting transparency because you can understand the data. You solve discernment because you have access controls. And then you solve context because that's what the graph is all about. So now I've basically solved these problems, which is pretty big. So let's now go into how do you build this. So I'll spend about, about 15 more minutes, and then we'll have 10 minutes for questions. So let's talk into the how now that we know the why. This is a big gaming company, so this is not my slide, it's just showing a customer, they have their domain layer, they use the term semantic layer to describe the graph, you sometimes hear that terminology. And then they have their agents on top of that, and then API layers and so on top of the agents. Another picture, this comes from Walmart, and this is a bit small, but you can see a link on archive.org where they have this paper published. They have 1.6 million employees that have access to a career advisor, and career advisory is a form of journey. It's the employee journey, and the employee journey is through a set of roles. You can represent those as a graph and through an org chart, and if someone wants to get to this particular role over here, and they're over here now, then based on where they've been and what the requirements are, you can actually just trace out what are the available paths and then show those back to someone and do it in a way that you can explain exactly, here's why, here's the path that you can take. So here you have users on the left, the people.ai knowledge graph, and then agents, and then various forms of tools that they hook in. And this is one from Uber, that looks pretty similar. You have the LM provider, and through an API gateway, through an agent, through an MCP server, and then a bunch of auditing and alerting and so on, and ultimately pulling back configuration of all of Uber's services in all the cities, so what services are available and what are their criteria, so that a driver can come in and ask a question about, does my car qualify for comfort in Lisbon? That actually gets answered through this system, which has a Neo4j database at the core of it. Okay, so if I want to build a graph, let's actually be a little bit more, go a step deeper, but still conceptually understand what kind of data goes into the graph versus what kind of data do you want to put into tables. And the way I like to think about it is, anything that shows up as a network of computers, network of people, network of communications, biology, transportation, payment, that's a network, that's naturally a graph. Like, of course you're gonna put that in a graph. That's a much better way to store it. Likewise with hierarchies, org, supply chain, bill of materials, asset ownership. You look at mutual funds, and it's like a fund that has some stocks, and maybe some ETFs, and then some options, and then this company owns this other company, and so on down the line. And then a graph database is just a way to expose a data model as a graph, so that you can take anything that looks like one or more networks, one or more hierarchies tied all together. And this is actually an ISO standard data model that Neo4j and other vendors implement. And I'd say the schema flexibility is a big advantage. The fact that models are better at writing Cypher queries than complex SQL queries is another advantage. And then another one is just impedance mismatch is the term that comes to mind for me, is that there's less of a distance between the way the data naturally wants to show up and the way I'm storing it. It's not like trying to model a network into tables, which is really hard. turns out there are multiple kinds of graphs that people are using. The obvious one is the domain graph, which is like the digital twin of the part of the world that you're trying to show, your payment network, your biology network. Another is you can actually create a graph of the vector chunks. So it's chunk, next chunk, next chunk. Chunk is in is in cell C2 of table 3 on page 32 in document X as part of this collection with this authors from this date and so on. That can be very useful, and you can actually tie these two together. And if you do that, you can use vectors to index into the graph and then traverse out to the domain. You can re-rank your vectors based on what is in those vectors and where those vectors are. There's an ontology graph, which is the graph of concepts in your domain. So this isn't the individual things, this is the kinds of things that you have. So if you think about, I don't know, a furniture vendor, a furniture vendor, you have furniture and you might have, that's a node, and then you have consumer versus business, and then under consumer you might have household versus outdoor, and then under household you might have kitchen versus dining room versus bedroom, and then under kitchen you might have table, and so on down the line. That's the ontology. I talked about memory and how you're seeing that. If you go to graphrag.com, there's more elaboration on that. And then you can also run graph algorithms, which are forms of unsupervised machine learning that'll do things like PageRank, which is actually what made Google initially dominate the web search wars in the early days, and then push that back to the graph and then use that for ranking or so on. Community detection, link prediction. This is used a lot in policing as where's the next link likely to form between, say, two bad guys. Okay, so those are the kinds of things you put into the graph. Now, how do your agents actually use the things in the graph? This is a little bit advanced, but I think it's a good background to have conceptually. One is hybrid search with graph context. This is saying I'm going to land in to the graph through a vector and then traverse out the domain graph and then bring that context back. That's number one. Number two is same thing, but now I'm going to filter. So based on the things that are associated with a domain, I can just define a pattern to filter for and bring back less of the graph. Another one is text to cipher, which is like text to SQL, except it's a graph query. This is when you're delegating queries over to the graph. Another is graph vectors. This is underused, but it turns out in the same way that you can have a vector that represents the meaning of a word and compare the distance between these two things and these two things and see, how similar are these two versus these two. You actually have a graph vector that represents, so it's a vector, looks exactly the same as the other kind of vector, but it represents the topology of the graph from the perspective of that node. Like, what is the shape around a high value customer? How do they engage? What's the shape of that subgraph right around them? What's the shape of a fraudster? It turns out these shapes are very different. And so you could then do similarity with something coming in and say, oh, this new node that I'm looking at actually looks more like a fraudster than a high value customer, or vice versa. That can be very valuable. I think there's a lot of opportunity here. A lot of people don't understand this one yet. GNNs is the other term you hear for this. And then last but not least, combining these together, just having multiple tools and patterns, either within the same application or different agents that work with each other. I want to take one step deeper and talk about, okay, if I'm writing a graph query, so in the realm of, think about this next slide as being in a drill down into text to cipher, and, well, it's a combination of these. What are the different things I can do once I have the data in my graph? One is I can query based on a pattern. Cipher / isogequal is just about, it lets you define a pattern, and you can look for that recurring pattern either anchored, so start with a customer and look for the pattern, like shortest path between two things. Or I can say, I know that this pattern represents money laundering. If I have this connected to this, connected to this, let's go through the entire graph and search for those. So that's transactional and analytic. This is the equivalent of OLTP and OLAP in the SQL world. The next one is graph algorithms, so these unsupervised machine learning that I talked about, clustering, centrality. Clustering is how do things naturally group together based on lots of people calling each other, say in a telco network. This group of people are friends, so they call each other a lot. This is friends, they call each other a lot. You don't need to know anything about their friendships. You can just look at the call records and infer the friendships based on who's calling whom, or work relationships and so on. And then you can find who's at the center of the network. Who's the person that calls everybody? Who's the person that everybody calls? Who's the person that sits between these two networks? Here are two cleats that never communicate except through this person. That can be really valuable in a lot of use cases. Another one is similarity and search. That's the one I talked about. So either full text, vector search, geo coordinates, etc. Another is GNNs, the graph vectors, and then for the humans, we have graph visualization, because there are some kinds of use cases where if you present the data in a spreadsheet, like fraud, I've seen this many times, a human might take 10 minutes of going through the data and identifying whether there's fraud. But if you serve it up as a graph, oftentimes you can just do pattern recognition. Oh, this has the shape of fraud. So visualization can be very, very powerful. Of course, if it's not a human, it's an algorithm, you can do that numerically too. All right, so to build, you're gonna need various building blocks to build. I'm gonna talk through 4 very quickly, and then I'll give you a link at the end where you can go and find these and other building blocks. But 4 of the building blocks that are important for using and building a knowledge layer are, the first 2 are around where does the graph come from? How do I build the graph? Usually it comes from one of 2 places. It comes from either full text or it comes from structured tabular data. So from a structured tabular perspective, I'm going to connect to Snowflake. This is Neo4j Aura is a, you can get basically a free database to boot up, and that's fully hosted. Or there's something called Neo4j Desktop, which you can run locally. So from here, I've got all these different options. I can import from Snowflake. On the left side, I basically pull in what are all the tables that are available. I can choose what tables I want. I can click a button, and I can, with AI, this will come up with a graph model. What's especially exciting to me about this is it used to take our professional services team maybe a week to work through what does the model look like, especially in something like Snowflake where you have no primary and foreign keys. You kind of need to know how the data is related. Now, this will just infer the primary and foreign keys based on like column names and stuff like that, come up with your graph model, and then you click another button and it'll bring all the data in. So in less than 10 minutes, you can do what used to take a week. So that makes it easy to bring data in from structured sources. On the unstructured side, here's an example. Microsoft has a super, super long website with over 300 references. And if you can do this with one document, you can do it with many. So I'm just gonna show you the one document example. There's this open source LLM graph builder that's also hosted to connect into an Aura database like I showed you, where I can just choose, I'm gonna pull in a YouTube video, a web page, PDF, I'll put in the Wikipedia page for Microsoft, and I'll give it some hints. I'll say, look for people that work for companies. Look for companies that launch a technology. Look for people that lead a company. So it's just a little bit of a hint to the LLM that's gonna be used to actually do entity extraction out of this body of text. And then you click a button, and then you basically end up with 3 different graphs. Remember I talked about the 5 kinds. I actually have 3 that were all just built like that. One is your document and chunk graph, that's a lexical graph. 2 is your entities, so that's your domain graph, entities and relationships. And then 3 is your communities. It actually ran some community detection in the background, so it ran a graph algorithm. Okay, what do you do with all of this? Then there's an example built in here where you can say, I can just ask a question. Who's on the board of directors of Microsoft? And under the hood, it's going to call an LLM, but first it's going to check whether the graph has any information that might help answer my question. So I get my answer back. For some reason it chose December 2023, and then here are the people. And it turns out December 2023 is the latest board information on the Wikipedia page. So it pulled from there, and I can then click on details to get explainability. And I can see here I have a board of directors node with a bunch of people. And then some of these people are or were Microsoft employees, and so on and so forth. There's a competes with Apple in here. You can see a few other things that pulled up. So pretty cool, right? Again, within a few minutes, you're able to extract data from a graph, ask a question, and get an exact explainable answer. In the real world, things are a little, can be a little bit messy, but this is a non-contrived example, and you can try it yourself. Obviously, if you have lots of data, there's techniques that are evolving day by day to be able to resolve duplicate like synonyms so that you don't end up with different nodes for things that you want to be called the same thing, etc. Okay, two more, and then we'll jump into questions. Of course, you want to build an MCP server so that you can do something like this. And this might be a little small, but it says, can you summarize this is in Claude Sonnet. Can you summarize my technical talent and skills distribution and the types of things people are working on? Feel free to include simple graphics. And Sonnet now knows to use the MCP server to take this, turn it into a question, call the API, and you can see the reasoning steps, and it comes back and gives you answers. So this is in beta now, and you're welcome to try it. And obviously you can build your own too, but we're trying to make it easier. So you can expose data from the graph to any agentic system, and then just go out and build projects. So this was the talent. This was the answer to the earlier question of what are people working on, and show me some stats. Looks like we've got a formatting issue there, but it's basically here are the current MCP servers that are available and that are growing. The first one's the most important, is just natural language decipher, which is what I just showed you the example of. But you can also use it to store agentic memory. You can use it to call cloud service APIs if you want to pause, resume, grow instances through MCP, through an API, modeling and data visualization, run graph algorithms, and so on. So here are some resources if you want to follow that link. That one is very much a living document, changing from week to week as it improves. Okay, next, last but not least, is building in terms of tools. Is for agents, it's actually handy if you can have a tool to build agents for you. So there's an agent builder that's currently in beta that's available in Aura, where I can create a GraphRag agent. So here you can just say, what's the agent called? What's it supposed to do? And then I just give it prompt instructions. And then I can add tools like text decipher, or a particular hard-coded cipher template, or similarity search, and so on. So this just makes it easy to build agents that you can then expose. And yeah, here are a few examples. I'll go quickly so we can get to Q&A. These are examples of the different tools. There's an agent testing playground, and then you can publish your agents. Cool, so let's wrap it up. There are lots of resources. Oh, before I get into that, one last generalization. So your startup potential, coming back to what are we all doing here and how do you succeed, is there's an opportunity for domain mastery and disruption, where as the world grows more mature and more competent at handling different kinds of use cases, there are many, many use cases that already exist where we're kind of at the inherent limits of what legacy technology can do. It's like diminishing returns. I'm not doing anything different with my data. I'm not doing anything materially different algorithmically. So we're kind of here, and then AI gives you the next step, provided you have the right architectural framework for your app and for your knowledge. So really your opportunity here is to master the architectural framework, pick the right opportunity, and then and then you jump up this next S-curve. So for further learning, I have one QR code at the end that'll link to all of these, but there's Graph Academy, where there's all kinds of training. There's a few courses at deeplearning.ai, and actually Andrew Ng and our CEO, Emil, spoke at our digital conference last week, where we actually had over 100 talks over 24 hours across all 3 continents. And then building, there are a number of books out there, including this O'Reilly book, a few books by Manning. And then if you want to grab that, we put together a bunch of resources, these and more, for Web Summit attendees, so that you can just jump in and follow that. And if you want to talk to someone, you can click through that too, but try to consolidate all the learning resources. All right, I think I did okay with time. We've got 5 minutes for questions. Go, over to you. Yes?
Do you see any potential in all the school semantic web technologies, such as OWL for ontologies, Shuffle for RDF recommendation, applying to this framing work?
Yes, so the question is, and I don't know how familiar everyone is necessarily with older semantic technologies, and specifically the W3C has a standard called the RDF, which was designed to essentially tag the World Wide Web and annotate things, and that's a popular framework for defining ontologies, and there's a lot of public data out there in RDF format. It's a good serialization format. I'd say for companies that are in industries where there's a lot of RDF data out there, that remains important, no need to change that. We on the property graph side are not trying to create new serialization formats because we already have that. And there's a bunch of import technology that exists to move between property graph and RDF. If you're building an application, property graph, the reason it's become an ISO standard and that it's become as popular as it is that it's just an easier model to reason about and to build with from a tooling perspective for your data. So you might have your ontologies over here in RDF, but your actual enterprise data and just being able to query it and being able to run queries as well. If you build a technology ground up for the property graph model, which I've spent the last 13 plus years doing, things that'll cause the largest relational database in the entire company to keel over because the queries take so long and grind away will run 1,000 times faster on 10 times less hardware. So that's an advantage that you have on the property graph side. So there's some complementarity, yeah.
So when you're integrating several databases and so on, this is basically the first point or the first step that you need in order to access this knowledge graph. Is the possibility to actually do this incrementally, I guess so, right? Like
that's right.
The data rows, the graph will be updated without having to read the whole thing.
Yes. So let me answer incrementally in 2 ways, because you need to be able to have a knowledge layer where as data changes, you can update it. So that's this first characteristic out of the 5 that I listed, where you need to be able to take transactional updates, and that includes being like on the receiving end of a Kafka sync, or just doing transactions. So you need that for sure. And that's where I'm adding more of the same kind of data. You also want to be able to build incrementally, where I build a 1 agent and it does customer service. Now I need another agent that does support, and I need the same data that I do for my customer service, or maybe I need 80% of the same data that I do for customer service, and I need a little bit more data. So you also want to be able to have room for incrementalism or incrementally adding new kinds of data. And to do this, what you ideally want is a schema flexible model. And what we've built in Neo4j is a schema, a progressive schema, where you can start out with no predefined schema, and then as you figure out what parts of your schema you want to lock down, you can apply schema constraints, but then still leave it open so that if you have new kinds of data that come in, those can come in, and then as those define, add constraints. So you have this flexibility to add new kinds of data, which is a big deal because things are moving so fast, and you want one layer to support multiple kinds of agents. You don't want to have to, there's the silo problem, but there's the data replication problem. You don't want the same data all over the place. It already is all over the place. Yeah. All right, one more question. Yeah.
How do you ensure data governance and different permissions in the knowledge layer?
Through fine-grained access control. So there's and if you're using Neo4j, there's a few different editions. There's Community Edition, Enterprise Edition, Aura and the Enterprise Edition have fine-grained access controls, and the Community Edition doesn't. But there you can have roles, and then inside the graph you can say this role or this person is able to create, read, update, delete, or create, read, update, delete this kind of node, this kind of relationship, this properties with this name. And we're just adding in, because you end up with customers who have more and more sensitive data, who want to go more and more fine-grained. We just added document level, where if I have data that's stored, let's say this document has a classification tag, a security classification, and then depending on someone's security clearance, you actually want your access control system to check whether their clearance is high enough to see a document where in a property on that document node, it says my classification is equal or less than to their to their access level. You can do that as well. So you can all the way from node and relationship level to property level to document level. Is that good? Cool.